As cities continue to become more urbanized, driving humans further and further away from natural environments, we have become more aware of the impact the built environment has on health, well-being, and sustainability. As a result, many urban residents are constantly searching for modern and sustainable ways to reconnect with nature. Due to these circumstances, biophilic design is a concept that has rapidly gained popularity in recent years, as it champions the health and well-being impacts of being connected to natural settings, striving to weave it into the design. Despite the advantages of this framework, after learning about some of the existing practices of biophilic design, I found that the application of the above framework in the field of product design is still limited. Designers almost exclusively use natural materials, colors, or patterns in an indirect way to create a biophilic atmosphere, which leads to a disconnect between design and its potential to promote well-being and foster a deeper connection with nature. Demonstrating a key contradiction in biophilic design practice, many designs stay on symbolic mimicry of natural representations rather than creating authentic interactions between humans and living organisms, which is contradicting the essential need to be biophilic. Therefore, in this project, I hope to promote a deep reciprocal relationship between city residents and natural beings, like plants in the city, by designing furniture that fulfills the instinctive needs of biophilia. How can effectively link citizens and natural livings in cities? Councillor Johnny of Kensington and Chelsea Borough mentioned that communities in London encourage residents to actively participate in the maintenance of public facilities and greenery in their community. Therefore, I think attracting residents to participate in the maintenance of community greenery is a good way to promote this interaction. Besides, through botanic research, I learned about the Voronoi diagram. It is a kind of tessellation which in botany they are used to model and analyze spatial patterns of plant arrangement. They provide a framework for understanding how plants use space, compete for resources, and develop complex structures. By incorporating biological rules and constraints into diagrams, researchers can create models that simulate how plants grow and adapt to their environment. By observing and collecting data on the growth of a native plant in the UK English ivy, and with the help of parametric techniques, I simulated the growth and developmental framework of English ivy using Voronoi diagrams. I have optimized this framework several times in order to allow it to be applied to furniture structures, improving from a 2D model that only calculates on the surface of the object to a 3D model that can calculate inside the volume has allowed it to generate a furniture structure that is more supportive and more in line with the growth habit of English ivy. I also conducted various experiments in the selection of materials for the bench. English ivy grows by constantly growing aerial roots that attach to the surface of the support, so the material needs to have a rough surface to make it easier to grow and cultivate. I found that by replacing some of the sand in the concrete with plant charcoal, I was able to create more pores on the surface of the concrete. This porous surface structure facilitates the root hairs of the ivy to penetrate deeper and reside, allowing it to climb more securely onto the bench frame. Finally, I designed this public green space bench made of bioconcrete bricks, which redefines the vitality of urban public furniture through parametric technology and living plant symbiosis system. Urban residents are able to let the ivy climb all over the base of the bench as they wish, and have a deep dialogue with the English ivy while using the bench, thus inspiring a sense of well-being and responsibility of their communities. The process of using it is very simple and does not require any specialized knowledge. Just plant some ivy next to the base and water the bench base regularly. After a year, the ivy will be free to grow on this bench. Due to technological limitations, current concrete 3D printing does not allow for making structures as complex as the Voronoi diagram. Currently, my prototype is achieved by 3D printing a play frame. In detail, the 3D printed brick frame is repeatedly dipped into concrete slurry to form a strong concrete layer on the surface of the bricks. In fact, This concrete layer is strong enough and weather-resistant. However, it is hoped that in the future there will be more advanced techniques or materials that will make this design better.